this is your review video for activities 25 and 26 in Unit 5. We're just going to kind of go through a select few problems, hopefully remind you of the procedures for each type of problem. So I'm going to start at the very beginning here with number 1. Because as I was helping people, there were quite a few people who forgot what they needed to do for Part A. So what Part A had asked you to do was to take the original function that they gave you, which was L of x equals the square root of x over 6, and they wanted you to write it as a transformation of the parent graph. Now remember, our square root parent graph transformations have to be in this form, where we've got an a value, an h value, and a k value. What's wrong with this is that this has a b value. Now, we've talked about b values before, but at least 4 different times within the lesson, we've talked about how we're not going to do b values for square root and cube roots. Now, if this says x over 6, remember that that is the exact same thing as saying 1/6 x. So these are identical, haven't changed anything. Again, this 1/6 is really a b value. That would represent a horizontal stretch. But again, because they're more difficult to graph, we're not going to deal with horizontal shrinks and stretches in this unit. So what we need to do is we need to give each of these their own symbol. So square root of 1/6 times the square root of x. Because when you multiply radicals, you just multiply what's underneath. So likewise, for instance, when we simplified radicals like this guy, and we made it 9 times 2, and then we gave them each their own symbol. We're doing that exact same thing, only with variables here. So we separate the 1/6 from the x, and now we're just going to simplify this guy. So if you were wondering how I got the 0.41, this is how I got the 0.41. I typed into my calculator the square root of 1/6. Make sure that you put the 1/6 inside the parentheses for the square root, otherwise you might get the wrong answer. So that should give you L of x equals 0.41 square root of x for the answer to 1A. So the next one that I want to talk about is on number 3, where it asks you why g of x's domain is from -infinity to 0 instead of from 0 to infinity. Now this, as well as our parent graph, if you look, part of 1b was to graph the parent and L of x together. So square root parent graph, hopefully we know by now, starts at 0, 0, and then you go right 1, up 1, right 4, ooh, that scale's bad, sorry about that, right 4, up 2. So this is our parent graph, and again, on this, the domain and the range are both from 0 to infinity. So what number 3 is asking is why the g of x that they give you in that equation is from -infinity to 0 instead of 0 to infinity. So this is what they gave you, and they're asking why. So the g of x equation that they gave you was g of x equals the opposite of the square root of x. So I think that you might be able to tell from my explanation, but sometimes it's hard to make type shorthand words fully explain. This graph, if you're asked why the domain or range is what it is, your best shot at being able to explain that well is to actually draw a sketch of the graph. Now again, a sketch isn't required here. It's kind of part of your work because all this has right here is the only transformation. And we should know that a negative a value means that what we're doing is a reflection in the x-axis, which means it goes 0, 0, but then instead of going right 1, up 1, it goes right 1, down 1, and right 4, down 2. So in red is what g of x would look like. So the reason why the or the range in this case, not the domain, the reason why the range is different is because we flipped it over the x-axis. So it decreases instead of increases. So the range here starts at 0, but it goes down instead of going up because our branch is actually pointing down. So sorry, I said domain a couple times in number 3. The question asked for range, not domain. All right, so hopefully that makes more sense than just the printed answer. Next one I would like to look at is, let's go with 5a to kind of do a warm up to 5b, which I definitely want to do. So 5a is a square root equation that we want to solve. So remember, all square root equations have the same 4 steps. Step 1 is to isolate the radical. Step 2 is to square both sides. Step 3 is to solve for x. And step 4, remember, is not optional on square roots. And that is to check for extraneous solutions. Remember that on this step, you have to show the work that you checked. It's not just mentally, I checked. I have to see it on your paper. So step 1, isolate the radical. That means I want to get this guy all by itself. So I'm going to subtract the 5 first. Gives me the square root of x minus 2 equals 3. So step 1 is done because the radical is by itself. Step 2, I'm going to square both sides. So square the left, square the right. On the left, the squared and the square root undo each other, so I've got x minus 2. On the right, 3 squared is 9. So now, get x alone, just step 3. I do that by adding 2, and I get x equals 11. Step 4, here is what we did in class. So if you've forgotten what I need from you in showing the work for step 4, this is what I need from you. Take the original equation and put 11 in for x. So 11 minus 2 plus 5. I'm checking to see, does that equal 8? So 11 minus 2 is 9. The square root of 9 is 3. So 3 plus 5 does equal 8, which means that x equals 11 is a valid solution. All right, let's try another of these with the same steps. Square root of x plus 2 plus x equals 0. So same steps. First I need to isolate the radical, in this case by subtracting x on both sides. So that gives me the square root of x plus 2 equals negative x. Radical is alone, so I can move on to step 2. I'm going to square both sides now. Remember that this negative is inside the parentheses. So on the left side, that just gives me x plus 2. On the right side, I get x squared. Now, this is different from the one that I chose in 5a because step 3 is going to be different. I'm following the same steps, but what I need to do to solve for x here is different because this equation is quadratic rather than linear. So to solve quadratic equations, remember we have to get it equal to 0. So I'm going to move these two terms over to be with the x squared term. So that gives me x squared minus x minus 2 equals 0. Most of our quadratic equations are factorable, so I always try to factor first. So you're looking to see what multiplies to negative 2 and adds to negative 1, which would be negative 2, positive 1. So factors into x minus 2 times x plus 1, equals 0. So you get two solutions here, x equals 2, x equals negative 1. Don't forget step 4. I need to check those for extraneous solutions. So plug each of them in. So I take the original and I plug in the 2. So square root of 2 plus 2 with another plus 2 on the outside. I'm checking to see if that equals 0. For the negative 1, got square root of negative 1 plus 2 minus 1, checking to see if that equals 0. So 2 plus 2 is 4, the square root of 4 is 2. 2 plus 2 does not equal 0, so this solution is extraneous, so I need to cross off my x equals 2. Now I'm going to simplify this. Negative 1 plus 2 is 1, the square root of 1 is 1, and 1 minus 1 is 0. So this one checks out, so x equals negative 1 is a valid solution. Remember that if one or both of the solutions that you get, if the only solutions that you get both don't work, or the only one you get doesn't work, that means the answer would be no solution. So this one isn't no solution, but again, that's when no solution happens. All right, next one that I want to look at is number 8. And it was multiple choice, but I want to make sure you understand why the answer was what it was. It gave you the parent graph of the cubic, which is the cube root of x, and it asked which of the following represents a transformation of a vertical stretch of 2. Now probably most of you immediately looked for something that looked, well, it wouldn't say f of x, it would probably say g of x, that would look something like this, a 2 in front with the cube root of x, because that's what a vertical stretch of 2 typically looks like. But you'll notice that in the multiple choice, that isn't one of the choices, because they're going back to what we did in number 1, where numbers on the inside have to be simplified to the outside. So that is why the answer is A, because if you look at that g of x equation, which was the cube root of 8x, when you give them each their own symbol, cube root of 8 times cube root of x, the cube root of 8 is 2. So that's why the answer is A. All right, next one I'm going to look at is actually the next one, because I want to make sure you know the shape of your cube root function. We already went over the shape of the square root function up here. So number 9 asks you to graph f of x equals the opposite of the cube root of x with a plus 4 on the end. So if you're describing the transformations here, which it didn't ask you to do, but you kind of need to do in your head in order to graph it correctly, you should see that there's a reflection in the x-axis because of the negative, and that this plus 4, since it's on the outside, represents a vertical shift up 4. So when you go to graph it, those are the changes we're making to the parent. So the parent usually starts at the origin. So because we have a shift up 4, our graph should start 4 units above that. So right here. It's reflected in the x-axis is the other transformation, which means that normally my branch to the right goes up. Now, because it's reflected, I need it to go down. Now, the pattern of points is still going to be the same. So instead of going right 1, up 1, I'm going to go right 1, down 1. So right 1, down 1 will be my second point. Remember, we generally want 5 total points, 2 on each branch plus the middle point. So after from the starting point you go right 1, down 1, you need to go right 8, down 2. Remember that this is a cube root. It has a different pattern than the square root. So there's one branch. I really highly suggest drawing the branches separately, because some of you are making the middle part not looked curved. You're making it look like a line because you're trying to connect it all at once. On the other side, same idea. We're going to go left 1, up 1, where normally we would go left 1, down 1, and left 8, up 2. Again, I highly suggest connecting the pieces of the branches separately as 2 different square root looking functions, so that you get the curve in the middle looking all right. So that is the graph that you had on your answer sheet. All right, next one that I would like to look at is number 13b, where you are solving a cube root. It was 5 cube root of x plus 1 equals 10. So steps are very similar to the square root, except that we don't have step 4, so no needed to check for extraneous on cube roots. And in step 2, instead of squaring both sides, we're going to be cubing both sides. So step 1 is still isolate the radical. I do that by dividing both sides by 5 to get rid of this. So that gives me cube root of x plus 1 equals 2. So now, again, I cube both sides, not square. That gives me x plus 1 equals 8. Step 3, solve for x. That's easy here. I just subtract 1, so x equals 7. Again, you do not have to check for extraneous solutions on cube roots. If you want to, it can help you know whether your answer is right or not, because if it doesn't work, that means you did something wrong, not because there's no solution. All right, that covers activity 25. Now we're going to move on to a couple problems from activity 26. When we started off in activity 26 there, the first question that it gave you was asking you to run a power regression. So if you have questions about those buttons, you should see me before you take your embedded assessment and or quiz. But you same steps that we've always done, inputting your data, running the regression. There are some of the steps written out for you, if you'll recall, on page 404. So if you want to look back at that to help you, but I'm not going to go through all of those steps here. What I am going to talk about on the regression is 1C, where it asked you to write and solve an equation to find the stopping distance of a car that's going 50 miles per hour. Speed was your y value. So when it tells you 50 miles per hour, that means you're putting 50 into your equation from 1a in place of the y, or the f of x. So the equation that you're solving is this one. 50 equals 4.55 square root of x. And then obviously I just solved that first by dividing by 4.55, which gave me 10.989. And then by squaring both sides. So that is how I got the 120.76 feet, because again, the x that I'm solving for represented stopping distance. So that is the equation that I solved by hand for 1C. Number 3 is graphing inverses here. So it gives you a table and asks you to graph f of x as well as its inverse on the same axes. I'm not going to write out the domains and ranges again because those are on your answer sheets and it's a lot of writing to do again. But as far as the actual graphing, I know that you can see the graph, but I want to talk about how we got that graph if you remember when we did those in lesson 26.1. So on this, if I count my 2's, let's say, to make sure I have plenty of space, the points that it gave me were 0, 0, 1, 3, 4, 6, and 9, 9. So my original, sorry, it's very crooked. Normally it's better than that. It's hard to use this bamboo tablet, so pretend that that looks like a square root function, but that's our f of x. So that part shouldn't be hard. It's just plotting the points that they gave you. Remember that if they give you an equation, instead of the points, all you have to do is make your own t-chart by plugging in x values. So once you have that, remember that the inverse is just switching the x and the y. So I just wrote out a new table. 0, 0 stays the same, but instead of 1, 3, it's 3, 1. Instead of 4, 6, it's 6, 4. And 9, 9 also stays the same. So 2 of the 4 points actually end up in the same exact spot. But I need 3, 1, which would be right here, and 6, 4, which would be right here. So you can see when I connect those dots, it was a little better than the first one, but not much. Here's f inverse. You can see, remember the eyeball check, if you look at the line y equals x, you should be able to reflect it across that. in order to eyeball to see if your graphs are correct. So that's how we came up with the graph. Again, domain and range, I'm not going to write them out, but I will talk about them. What I always do is I look at just the original. Its domain started at 0 and got bigger. Its range started at 0 and got bigger. And then I just remember that an inverse, the original's domain is the inverse's range and vice versa. So I don't actually do it twice. I just switch the domain and range from my original to get the inverse. All right. Next one that I want to look at is number 7, where you are finding the equation of the inverse algebraically. So you're starting with h of x equals 5 times the square root of x minus 1. So first thing that I have to do is replace function notation with a y. So y equals 5 square root of x minus 1. Step 2, and these are the steps. If you need to go back and look at them, this is in lesson 26.1. All the steps are right there on page 401. After you put the y in for function notation, the next thing you do is you switch the x with the y. All right, now I need to get y alone. First thing I need to do is get rid of this 5. So divide both sides by 5. That gives me x over 5 equals the square root of y minus 1. If I'm trying to get y alone, the next thing I need to do is to square it. So square both sides. When I square the left, you have to square the top and the bottom, so that gives you x squared over 25. On the right, the square root and the squared disappear, so you get y minus 1. Last step to get y by itself is to add 1 to both sides, so you end up with y equals x squared over 25 plus 1. And then I put my inverse notation back in place of the y. Now, I had put on the answer sheet that you could also write that 1 over 25x squared because those are the same thing. It had asked, is the inverse a function? Yes, the inverse is a function. You don't even have to find the equation to know that it's a function. Remember that you can look at the original. If the original passes the horizontal line test, then the inverse has to be a function. All right, so there is 7. 8 is another one where it asks you to graph the original and its inverse. You can see the graph on your answer sheet there. I'm not going to go through all of that graph again, but notice that this time it doesn't give you the t-chart. You have to make your own. So you take the equation that they gave you for f of x and you make a t-chart of some values. Now, sorry, got a tickle in my throat there. Number 8, it's a parabola. So make sure when you plot the points that you're picking points on both sides. Otherwise, you're going to end up with the wrong kind of shape. But you should know that that's a parabola because it says x squared minus 4. In fact, you should be able to graph that without making a t-chart because all it is a vertical shift of the parent function. All right, number 9, second to last one I'm going to do here. Number 9, gave you an original function and asked whether we needed to restrict the domain of the function to ensure that its inverse is a function. So the function that they gave us was x minus 5 squared plus 3. So all I did to solve this, and there are multiple correct ways to solve it, so if you got the same answer I did and you did it a different way, that's okay. What I did is I looked at this guy, and I said, okay, I know what that looks like because that is a quadratic parent graph shift. It's shifted to the right 5 and up 3. And so I just drew a very rough sketch of where my vertex would be, the fact that it's a positive parabola, so it would open up. Now, the question asks, do I need to restrict the domain in order for the inverse to be a function? The original is a function. But in order for the inverse to be a function, remember that the original has to pass the horizontal line test, and this guy doesn't. It touches twice. So yes, you need to restrict the domain. In order for the original to pass the horizontal line test, you need to restrict it so that it's only 1/2 of the parabola, which is why there were 2 different answers listed. You did not have to have both of them. You only had to have one. You could take the right side of the graph and restrict the domain to x greater than or equal to 5. If you do that, then you will end up with a square root function for the inverse. If you take just the left side, which x less than or equal to 5, your inverse would be a reflected square root function. So I wanted to make sure you understood why the answer was the answer. Certainly you could, just from the shifts, know where the vertex is without drawing it, and if you do, that's great. All right, last one I'm going to do is number 13. F of x equals 2x plus 3 raised to the 1/3, and the directions asked you to algebraically find the inverse. So same steps that I just did here in number 7, but this is a different type of equation. This is a cube root instead of a square root. So in the step where I replaced function notation with y, I'm also going to switch out this 1/3 exponent for a cube root instead, because I think that that's what most of you prefer to do. Okay, so I put y in. Next step is to switch the x and the y. So they flip-flop places. Notice that everything else stays the same. I haven't moved the 2, I haven't moved the 3, I haven't moved the cube root. I just switched places with the x and the y. Now I need to get y alone. In order to do that, I need to get rid of my cube root by cubing both sides. So I end up with x cubed equals 2y plus 3 in my next step. Y is still not alone because my next objective is to get y alone. So first I need to subtract 3. So that gives me x cubed minus 3 equals 2y. And then I still have yet one more step. I have to divide by 2. So that gives me y equals x cubed minus 3, all divided by 2. And again, we put f inverse, I don't know why I keep writing that negative twice, f inverse of x equals x cubed minus 3 divided by 2. So there were a lot of steps here in that step 3 to get y alone. This is my inverse function. I did want to say, and I didn't put this on the answer sheet because I didn't think a lot of you would do it, but if you did write this 1/2 x cubed minus 3 over 2, that's perfectly fine. You would not lose any points for that. Those are equivalent expressions. So either of those would be perfectly great. All right, make sure that you study for the embedded assessment by actually doing the embedded assessment and kind of going back through your lessons and homeworks and all of that as well. That is all.